Hello, I'm back, and so why don't we make a list of what we've learned so far? So we've learned that you can measure the distance to a star. We've learned that we can measure the brightness of that star. And now we've learned that we can measure the mass of the star. So the next thing that we're going to be interested in is measuring the temperature of the star. Now, this is not going to be the temperature inside the star. This is going to be the temperature of the surface of the star. And we're going to do that by using Ven's law. And so if you recall from lesson number 6, we had two equations that allowed us to calculate properties of a black body. So there was Stefan's law, and then there was Ven's law. So this one is Ven's law. And if you recall, a black body, so this is going to be over here, this is going to be the brightness of an object. And then over down here, this was the wavelength or the color of the object. And then a black body looked like this. And then it turned out that for a particular temperature, the black body would have its maximum value at a certain wavelength. So we called that the maximum wavelength, lambda maximum. And so we had this formula that said that the maximum wavelength is equal to 0.0029 divided by the temperature in Kelvin. And then that would be the temperature of that black body. So all we've got to do is, with our telescope, we point it at the star that we're interested in, and we put either a prism or a diffraction grating on the telescope. And then what that does is it gives you the rainbow of colors being produced by that object. And then we look for the brightest color. So the brightest color is going to correspond to that lambda maximum thing. And then we plug it into the formula, and now we can measure its temperature. Well, it turns out, before we do that, let's do a worked out example. So a star has its maximum intensity at a wavelength of 1 times 10 to the negative 6th, 9th. You can read it. What is its temperature? So first we're going to write down what we're given and what we're looking for. We're trying to find the temperature, T. So we go back to our working equation, which is Ven's law, and we plug in our number for the wavelength, and we solve it for T, and you can see what that temperature turns out to be in Kelvin. So again, that's the surface temperature of that particular star. All right, now let's go a little bit further. So astronomers, again, have measured the spectrums of thousands of stars. And one of the things that they noticed when they looked at the spectrums was that sometimes there would be emission lines would appear at certain temperatures, but then at other temperatures, those emission lines would disappear. And so what it meant was that at certain temperatures, certain elements would begin to react. So do you remember that an atom has the electrons and they're on different energy levels? And when the electron jumps up, it absorbs energy, and when it comes back down, it emits energy. Well, those electrons for different elements behave differently. So the temperature at which, let's say, helium, their electrons jump up and down, is going to be different than the temperature that calcium will react at. So different elements will start to give off different colors at different temperatures. And so astronomers made up a series of letters. I don't exactly know where this series of letters comes from, but they're called classes of stars. So you have, for example, an O-type star, or you have an A-type star. And depending on its class, it's going to be at a different temperature, and then based on the temperature, different elements will show up in its spectrum. So I can't resist. Gene Roddenberry. All right, so Gene Roddenberry was the creator of Star Trek. And Gene Roddenberry was going through an astronomy textbook, and he noticed this series of letters that represented different kinds of stars. And he said to himself, I know, I will make up a series of letters that represents different kinds of planets. So that if a planet was like Mercury and it was really, really hot, we're going to call it this particular letter. Well, what letter did he choose to represent an Earth-like planet? Okay, it was a Class M planet. So the members of the Enterprise were always beaming down to Class M planets, mainly because he didn't have the budget to be beaming down to one of these more exotic kinds of planets. And as a matter of fact, all the planets that they beamed down to look like Southern California, because after all, that's where the series was filmed at. So again, this class is going to make you popular. You've got lots of useless information now that you can present at the next dinner party that you go to. So, how does this help us? Okay, so getting back to this. We take our diffraction grating, we put it on the telescope, we look at the spectrum of the star, and we look for certain elements in that spectrum. And then once you know the certain elements that are in the spectrum, you find them on that chart, and then that tells you the temperature of that star. Let's take a break. And when we come back, we are going to talk about the radius of a star.